Hey everybody, Mr. Stewart here, and welcome back to another awesome video at Math We've Got This. In the last video, you were introduced to how to represent an algebraic equation using algebra tiles here at Mathagon, specifically using the PolyPad algebra tools. So here was the equation that we broke down into both its sides, and we represented it in words, we represented it in terms of tiles, and then we actually collected like terms and we simplified it down to just how many x tiles and how many units we had altogether. We also looked at what it meant to subtract a group of tiles, or a group, or as an algebraic expression. So remember, subtraction is the addition of the opposite. So we applied that rule and rewrote the right-hand side of the equation, and then we represented it visually with tiles. So here we are at this part where we are going to now solve this equation using a balance model or a balance analogy. So what you do is you just grab the balance tool or the balance PolyPad tool, and we're going to take each expression we've built and we're going to bring that down inside this area. You can see how it's sort of highlighted, so make sure all the tiles are inside of that, and there you go. So you can see we've added a bit to that side, so the pan has dropped on the left and the scale should tip back a little bit to the right here. It doesn't necessarily mean that they're equal in size right now. In order to make sure that they are equal, you'll notice that it's not showing up here, but if I were to bring in a new balance, okay, and I were to click on, let me add just a few random tiles here just to prove a point. So if I were to just throw in a couple tiles here, just for the sake of having a couple tiles, to balance that out, I would have to click the balance key. Okay, so make sure that you do that before you do anything else. Okay, let's get rid of those. Now, okay, back to solving. So the idea, of course, when solving an equation is to ensure that you have an x tile. That is a positive x term and only one of them on one side of your equation. Okay, so notice that we have two positive x tiles here, one negative x tile over here. What I'd like for us to do is to remove that negative x tile from the right side, so we can create a zero pair here. And then what you do to one side, we must do to the other to restore balance. Okay, so we removed the x term from one side of the equation, brought it to the left, where we have positive x terms. So now these unit tiles. Notice that on the right-hand side, we have actually some zero pairs. So why don't we just zero these out, just to simplify things a little bit? Okay. In fact, we could have done that earlier on in our solution. Notice that zeroing on one side doesn't impact the equality because the pan has not changed in terms of its level. Now, again, I mentioned that before. What we could have done is at this step, we could have ended up subtracting the 2 units from the 6 positive ones. So that would have given us the 4 that you see here. Okay, but that's okay. We can do that at any time. Now, the idea is to get all of the unit tiles over to the right-hand side because we really want to isolate or get by themselves the x terms so we can solve for x. Well, the only way that we can do that is to take all of these tiles and add their opposites to them. So what I'm going to do is I'm going to copy them and I'm going to negate them just to make it easier so we're not pulling in a bunch of negative tiles. So notice how it still remains balanced. So now I'm going to zero out all of these terms. And because I've done that to that side, okay, what we need to do is we need to bring those negatives over to the right-hand side, because what you do to one side, you must also do to the other, okay? And it's still balanced because, as I just mentioned, we're performing the same operation on both sides. Last but not least, we need to zero out any positives and negatives that we have, and then we solve for x. So at this point, I'm going to remove the balance scale, okay, just so I can more easily sort things, and I'm going to group. So for each x tile, just put them out here, we'll do some division, right? We'll create groups of. So we'll put one here, we'll put one over here, and one to this one, and we'll just keep on going. And as you can see, what's going to happen is we'll end up creating three groups of -3, and that means that the solution to our equation is none other than x equals -3. And there you go. That's our solution.